So here we are at the last video of this section. Building a face recognizer using local binary patterns histogram. In the previous video we learned how to perform blind source separation. In this video we will finally dive into building a face recognizer by utilising local binary patterns histogram. We're now ready to build a face recognizer. We need a face dataset for training, so we've provided you a folder called Faces Dataset that contains a small number of images sufficient for training. This dataset is a subnet of the dataset that is available at this web page. So this is the faces.tar file you can download. This dataset contains a good number of images that we can use to train a face recognition system. We will use local binary patterns histograms to build our face recognition system. In our dataset you will see different people. Our job is to build a system that can learn to separate these people from one another. When we see an unknown image, this system will assign it to one of the existing classes. You can learn more about local binary patterns histogram at docs.opencv.org. Let's not wait and finally move ahead to see how to build a face recognizer. So we start by creating a new Python file, and here we have named it facerecognizer.py. Now import these packages in the initial lines of the code. Let's define a class to handle all the tasks that are related to label encoding for the classes. Next we define a method to encode the labels. In the input training data, labels are represented by words. However, we need numbers to train our system. This method will define a preprocessor object that converts words to numbers in an organized fashion by maintaining the forward and backward mapping. Then we define a method to convert a word to a number. Also, we need to define a method to convert the number back to the original word, so we do it here. Let's now define a method to extract images and labels from the input folder. Now recursively iterate through the input folder and extract all the image paths. Next, initialize variables. Let's pass the input directory for training. Read the current image in grayscale format to extract the labels. And now perform face detection on this image. We now step ahead and extract the ROIs and return them along with the label encoder. So let's now define the main function and define the path to the face cascade file. And you can see our main function here. Now load the face cascade file. And create local binary patterns histogram face recognizer objects. Then extract the images, labels and label encoder for this input path. After this, we train the face recognizer using the data we have extracted. Let's now test the face recognizer on unknown data. And here we load the image. We also need to determine the location of the face using the face detector, so we insert this code for it here. For each face ROI, run the face recognizer. Next, we convert the label to word. And now overlay the text on the output image and display it. Let's check whether the user pressed the escape key. If so, break out of the loop. So let's go back to command and run the file. The full code is in the facerecognizer.py file that's already provided to us for reference. So as you run this code, you'll get an output window which displays the predicted outputs for test images. You can press the space button to keep looping. There are 3 different people in the test images. The output for the first person looks like this. This is the output for the second person. And this is the output for the third person. Fantastic! So, in this final video we've successfully built a face recognizer with the help of local binary patterns histogram. To summarise the section, we started with capturing video from a webcam, and then building a face, eye and nose detector. Next we performed kernel perform components analysis and blind source separation. Finally, we built a face recognizer. In the next section, we'll learn about deep neural networks.